All right, this video is going to talk about how to graph sine and cosine functions. And the first thing we need to know is, where does the shape of a sine or a cosine function come from? And why do we call them periodic functions? Well, the main idea is we start with what we have known from the unit circle previously. So if we think about the sine function, I know it's on the bottom here, but let's talk about the sine of theta first. If you look at a unit circle, such as the green circle over here at the right, anytime we draw an angle, right, on our unit circle, we're always saying that the sine is the opposite, right, of our angle. So our y-coordinate divided by r, or divided by the radius of the circle, which on a unit circle, again, would always be 1. So notice that the y-coordinate at 0 degrees would start off down at 0. Then we would increase, right? We would reach 1/2, think of it that way. If this were a 30-degree angle, right? The sine at 30 degrees is always 1/2. But then we're going to work our way up, again, through 45 degrees and 60 degrees and all those other angles to a maximum, right? The highest the y goes is up here at 1. And then notice after that, it's going to work its way back down again, right? We're going to kind of keep working our way around the circle. And we're going to go back down to 0. And then basically repeat the same pattern. That same semicircle happens, but only it's going to happen negatively, right, when we get down here at the bottom. So we're going to keep working our way around past -1, right? And then keep working our way around the circle. So notice that the sine again starts at 0, 0. We would get up to about 1/2. This looks like at about 30 degrees right here, right, if we were in degrees. And then we would keep working our way up to 1, and then back down to 0. And then, like I said, that bottom half of the circle is going to work there. Again, this would be at pi, because we're halfway around the circle. This would be about 2 pi, because we're all the way around the circle. So again, we're going to get this simple sort of S-curve going on there. Then what we want to realize is, again, if we kept going around the circle again, right, if we just made another path around the circle, this same exact pattern would happen again from 2 pi to 4 pi, and then from 4 pi to 6 pi. Again, it's just going to repeat itself. That's why we call it periodic. We call that the period, right, being 2 pi. Every 2 pi radians, right, of 360 degrees, we're going to repeat that pattern. Now you'll notice up top, the only real difference to a cosine is that, again, cosine corresponds to the x-coordinate. So again, x would start at 1, right, 1 unit out. Then it would decrease, right? We would go down to x being 0 up here at the point 0, 1, right? So notice the cosine starts up at 1, then it works its way down to -1 and back up to 1 again before it starts to repeat itself. Let's look at those fine-tuned details. A couple of the major things we need to know about sines and cosines are, what are their amplitudes and periods. We're going to look at a fairly simple set of graphs today. We're not going to shift them around at all. If you're familiar with shifting or translating your functions, we're just going to talk about 2 things today. Number 1, the amplitude. What's half the total height, right? Half the total height, or the distance from the middle to the top or the middle to the bottom of our function. Well, the amplitude for a sine or a cosine, because again, they're based on that unit circle, is typically going to be 1, right? Unless we stretch them. And again, we can always stretch a function vertically by multiplying it outside the function. So notice that a value. That's why we say that the amplitude is equal to the absolute value of a up here. Again, if it's negative, that's going to reflect our function. So instead of maybe the sine starting out going upwards here, it would have started off going down instead. We'd reflect that over the x-axis. But again, the amplitude is still half that total height. The total height is 2, right, from -1 up to +1. But again, half that height is just a 1. The period, on the other hand, is the distance from left to right that it takes for our function to repeat itself. Oops, went a little far there on that one. And notice it goes 2 pi units, right? 2 pi, 1 full circle, before it repeats itself. Cosine works the same way. Again, it starts at 0, 1. But again, the amplitude is still 1, total height of 2, amplitude of 1. And the period, again, is going to be 0 to 2 pi, right? Or essentially anywhere we went in here, 2 pi units apart, we would be exactly at the same spots, right? Whether those are maximums or whether those are points on the equilibrium, right? Where we go up from there, and then we start going up again when we're exactly 2 pi units away. So again, period generally is 2 pi. Now, that can change as well, because just like the amplitude could be stretched if we multiply outside, the period could be stretched or shrunk if we multiply on the inside. But now remember, that's a backwards idea, that horizontal idea. If you multiply by a large number, the period's going to shrink. We're going to actually divide by b. 2 pi over b is actually how we'll find the period. Let's look at a couple examples very quickly here and figure out why these details sort of are what they are. And then maybe in a second video, actually, we'll look at a few actual applied examples, and you can see how to graph a sine or a cosine individually. But again, the fine-tuned details of sines and cosines, the maximums, again, are going to be as high as they go. So notice, again, the sine is the yellow curve up top here. The highest that it goes is going to be up here at 1. And again, that happens at pi over 2. So you'll notice we're going to be at pi over 2. Or plus or minus 2 pi n. If we add 2 pi, we'd be at another maximum. If we subtract 2 pi, we'd be at another maximum. Every 2 pi units, again, where n has to be an integer. Oops, that's a really bad equal sign. Integer, right? N has to be an integer. So it can be one full cycle forward or one full cycle backwards, right, from where we are. Cosine is going to work that same way. It's also going to be a maximum up at 1. But again, it started at a maximum. If we're thinking about our y-intercept at all, we may as well open that up. The y-intercept for the cosine is 0, 1. And again, 2 pi units to the right or 2 pi units to the left will still be at a maximum. Halfway between those maximums, again, we're going to be at the bottom of our curve. So we're going to be down here at a minimum. So if it's 0 to 2 pi, again, at exactly pi units, right, we would be down here at a minimum for the cosine. Same thing goes for the sine, exactly 2 pi apart, but again, halfway in between will be down here at a minimum. So think about that at 3 pi over 2 would be a good first one there. Or if you backed up, you could even think negative pi over 2 would be a good place to remember. That's a first minimum for a sine value. Now, I don't usually worry about the sine value being maximums and minimums. The more important part is where to sort of start your graph. And a great place to start your graphs are at those y-intercepts. Again, cosine's great to start up at 0, 1. Sine is great to start at 0, 0. Notice it starts right at the origin. If we haven't shifted these around at all, right, we're going to start right at the origin. The domain, again, left and right, well, notice there's nowhere really missing. There's nothing we cannot plug into a sine or a cosine. We can plug any angle we want, and that, again, on your calculator would depend on if you're in radian mode or degree mode, but you can plug any angle you want into either a sine or a cosine. So thinking in interval notation, thinking all real numbers, negative infinity, all the way up to positive infinity. The range, on the other hand, is very limited. We minimize down at that negative 1 value. We are maximum up at that positive 1 value. So the range for both of them, again, is going to range between negative 1 and 1. The last part of the x-intercepts, and they're very helpful to graph as well, especially if we haven't shifted our graph around. Again, if the sine value starts at 0, 0, again, 2 pi units away, we're going to be at 0. We're not going to have gone up or down at all, right? We're going to be at 2 pi, 0. But again, halfway in between, right? After we do that top portion, then we do the bottom. Again, halfway in between, we also cross that x-axis. So the x-intercepts are only going to be pi apart, right? For every integer, they're going to be 1 pi down, 2 pi down the road, or negative pi, negative 2 pi. Again, we're kind of hitting that x-axis every pi units. Cosine is going to sort of work somewhat the same way. Again, because we started at a maximum, our first x-intercept, a great place to remember, is pi over 2. And again, that's going to happen every pi units, every half period, right? Pi units down the road. So 3 pi over 2, 5 pi over 2, 7 pi over 2. Again, every pi units, those are going to happen. Again, I hope that helps you with the details of sines and cosines. The major idea is where do we start? And then how can we use those amplitudes, right? How high and low to go, and periods to help us graph these functions. Again, this was video 1 of 2. Don't forget to watch the second video because that's going to help you with some actual examples showing you how to find the amplitude period and how to use them to actually graph these functions. If you have any questions about the details of a sine or a cosine graph, though, talk to your teacher, and otherwise have a great day.